All right, okay. So we have discussed the second chapter, that is functions. We are done with the initial units. We know how to find the domain. Technically, the questions we have seen so far had the domain already in the question part. Then we know how to find the range. We know how to find the inverse function. We have discussed composite functions, and today we will be discussing the domain and range of inverse functions. Okay, so yesterday I wrote some definitions. We did not use them. Today we will be using that part, and once we are done with this, by the end of this class we will be talking about a few past paper questions, just so we get to use our knowledge. Okay, so forget about everything. Let's just talk about inverse functions for now. That is the third unit of the second chapter, basically. All right, so we know how to find inverse of a function. Let me just write down a question and then we'll solve it. And then we will move to the past paper questions. All right, okay. So yesterday we were discussing a question, and I'll just write down the second part of it. It's question number 1 for today. So we had a function f of x, and it was defined as 5 minus x minus 2 whole squared for x belonging to the set of real numbers. And then we had a specific interval for x. It was between k and 6. This was the question, and then we were asked to find the smallest value of k for which f has an inverse. Now I'll just give you a quick summary or a quick recap of what we discussed. We know that a quadratic function originally or initially is not one-to-one. It is many-to-one, right? Because let me quickly just explain that part as well. It's important. The graph, I'm just making a rough sketch of what we had yesterday. This was the rough sketch, and you can clearly see that now if I make a horizontal line, let's say something of this type, the line would be intersecting the graph at 2 points. If I make the line here, everywhere the line is intersecting the graph at 2 points. So using the horizontal line test, or just by looking at the appearance of graph, I clearly know that for two different values of x, I have one value of y, and this is certainly a many-to-one function, and a many-to-one function cannot have inverse. Okay, so the first part that we have already discussed said, state the smallest value of k for which it would have an inverse. So we discussed that thing already. That is only possible if I talk about half part of the graph. This is how it was. Let me just erase these red lines, because now we are done with the horizontal line test. We get the idea. This point was basically 6, and now this, the vertex, the x coordinate of the vertex would be k, because if we talk about this part of the graph, I'll make it again. Something of this type. Now this was basically k. This was the x coordinate of the vertex. This now would be 1-to-1, but initially if I talk about the entire shape, it was something of this type. This is not 1-to-1. Okay, this is not 1-to-1. So in order to make it 1-to-1, we had to just restrict our domain between k and 6, and the smallest possible value of k in this scenario was basically the x coordinate of the vertex, and that was 2. Okay, this is why it was 2. So it would be 2. So this was something that we discussed yesterday. Okay, now we got the value of k as 2. Let's just talk about the second part of the question. And we will be doing multiple questions of this type, so don't worry about it. I can understand things won't, you won't be able to understand everything very easily. It would take some time and then it would get okay. Acha. The second part of the question was, I'm directly talking about the second part now. For this value of k, that was k equals to, find an expression for f inverse of x and state the domain and range of this. All right, okay. So the first part was already done. For the second part, it says, using this value of k, that is k equals to, find an expression for f inverse of x and state the domain and range of f inverse of x. Okay, so this question has three parts. We need to find the inverse function, we need to find the domain, and we need to find the range. Let's just talk about the first part for now. Let's talk about the solution. And now I will work on finding out the inverse function. Okay, so for the inverse function, again, step one was writing y instead of the function's name. So I will be writing y instead of f of x. So it is y equals 5 minus x minus 2 whole squared. This is going to be the first step. For the second step, I need to interchange x and y. Step number 2, I'm just writing step 1, step 2, step 3 for your understanding. You can just do it directly as well. Okay, that would not be wrong. Acha, so it would be x equals 5 minus y minus 2 whole squared. I've just interchanged x and y. And then step 3 is to make y the subject. So for making y the subject, I will just do it my way. You can do it your way. That's completely fine. I'll just take this entire thing on this side and it would become y minus 2 whole squared, and I will take this x on the other side. So this would give me y minus x. Okay, then I need to make y the subject. So I'll be taking under root on both sides. But I will take under root on this side. Here we initially had a square. And then under root 5 minus x. This and this would be cancelled. And I would be left with y minus 2 equals under root 5 minus x. And finally, it would become y equals 2 plus root 5 minus x. Now, by the end of step 3, y is the subject. And finally, at the end, I just need to write y as f inverse of x because this was the question, okay? So f inverse of x is basically going to be 2 plus root 5 minus x. Okay. Now please tell me anything that you were not able to understand while finding the inverse function.
No, ma'am.
Okay, very good.
Yes.
Yes.
Miss, before the root, will we be writing plus minus?
No, because here technically we just added the root, right? We added the root, and also another thing I'll tell you, this is a rule in general. Even I used to get confused when I was of your age. Just know one thing, whenever you have a variable kind of thing inside the root, for example, let's say you have y equals x, and now you need to add root on both sides of the equation. For example, okay, since we have a variable over there, so when you will add the root, you won't write down plus minus, or when you will basically, let's say if you have 25x, and if you have root, and if you want to remove this root, you can say technically that 25 root could be +5 or -5, but we are not sure about this x. So in general, just make it a practice whenever you are adding root on a number, right? If it's 25, 64, 8, 10, a mathematical value, certainly you will be adding plus minus. But whenever you will be adding root on an expression that contains a variable, you would not be adding plus minus. That is the rule in general, okay? Now, since here we added root on 5
Okay.
minus x, so if x is a variable, that is why we would not be writing down plus minus here. Okay?
Okay, miss.
All right. And Munja, any confusions?
No, ma'am, on the track.
All right. Okay. So Rafe had a very good question, and I would agree. I used to get confused with the same thing, but the idea should be clear. Whenever we have a variable, and then when we are adding under root, you don't write down plus minus. But whenever you have, and you will notice that in future as well, unless then we have, it could be that we had some constant. Now you need to be clear between the difference of a constant and a variable. Okay, but forget about it for now. Whenever I will, we will come across such a situation again, I will discuss that again. Okay. For now, this was the first part, and this is how we find the inverse of the function. That's easy. The second part says, state the domain and range of the inverse function. Okay. Now, this is my inverse function. Now, I do not know how to find the domain. Like technically the examples we have been discussing, the questions we have seen so far, we had the domain in those questions. Okay, this was clear from the very beginning, and we were finding the range. But what about such scenarios? How do we find the domain of inverse function? We know once we have the domain, I would be able to find the range, but how do I find the domain? So we have a rule here. Okay, and this is what I wrote in the very beginning of yesterday's class. For inverse function, we need to look at the actual function. Now the examiner wants you to state the domain and range of the inverse function. I can write it this way, that the domain of the inverse function would be same as the range of f of x, and the range of inverse function would basically be same as the domain of f of x. This is a rule, okay? This is a rule. Whenever you have been asked to state the domain and range of inverse function, you're not supposed to waste your time and do everything for the inverse function. No, because you cannot. What you can do is you can just find the domain and range of the actual function. So if the question is about the domain of inverse function, just write down the range of the actual function. And if the question is about the range of inverse function, just write down the domain of actual function. Okay. So this is how we would be solving this question. All right. Okay. So again, I will write down the question here, like the function here. Now we're talking about the second part. So again, it's going to be solution. Okay. And now let me just quickly write down the function. It was f of x equals 5 minus x minus 2 whole squared, and the domain. Now we will be talking about the domain and range. Okay. So again, you would get to revise that old content. The domain of the function is basically that x belongs to the set of real numbers. That is okay. But the actual domain is basically the interval of x. That was 2, like it was k. It was between k and 6, and k turned out to be 2 for the previous part. So it would be 2 less than equal to x less than equal to 6. So think about this as a new question. Okay, this is a function, and here is your domain. Here is the domain. Okay, and the question is about finding the domain and range of the inverse function. So I've just told you the rule. You just need to know the domain and range of the actual function, and then I will tell you how to just rewrite it for the inverse function. So we already have the domain of the function. We are only supposed to work on the range of it. Okay. So range of f of x. Okay. Now, when we will talk about the range of f of x, what we usually do is we just plug in this value of x or the domain and this value of the domain in the function to find the upper and lower limits of the range. But at times, graph of that function is important in order to understand the question. Okay. So let me quickly make the graph again. Okay. And initially we had the complete graph, but now since the range is from 2 to 6, so I would only be having this part of the graph. All right, okay. So this was 2 and this part was 6. Okay. Now you can clearly see this is my y-axis and this is my x-axis. Okay. Now you can clearly see when we talk about the domain, we look at the x-axis, that part is done. When we talk about the range, we look at the y-axis. So it's basically these 2 points. So at this point, the x coordinate is 6. And what about the y coordinate? In order to find the y coordinate here, I will do f of 6 and it would give me 5 minus 6 minus 2 squared. So it's 5 minus 4 squared. So it would be 5 minus 16 and this would give me minus 11. So the y coordinate of that point is minus 11. So this is minus 11. And if I talk about this point, the x coordinate is 2. And what about the y coordinate? Again, for this, I need to do f of 2. When I will do f of 2, it would give me 5 minus 2 minus 2 squared, and that is just going to be 5. So it's 2 and 5 and this point is 5. It's simple. The question was about finding the domain and range of the inverse function. We don't know how to do that. We need to find the domain and range of the actual function. The domain is usually given. We need to find the range. In order to find the range, yes, you can directly plug in the endpoints of the domain, but you will see in some cases the graphs are important. Okay, so we will just make it a practice. Sketching of graphs is part of your syllabus, so just make it a practice. Whenever you come across a question of this type, just make a rough sketch just so you're sure about the answer. And now if I look at the y-axis, I can see that my range is between minus 11 and 5. So I can directly just state the range. For range, I write down f of x and it's greater than equal to minus 11 and it's less than equal to 5. This is basically the range. And now I am directly going to write down the domain because I have that already. The domain of x, or sorry, the domain of f of x, the domain of this function is going to be, now we had f of x here because we were talking about the range. Now we're talking about the domain. So I would be writing down x and it's given, it's greater than equal to 2 and it's less than equal to 6. Okay, so the domain was already given. Using the domain, I sketched the graph and looking at the y-axis, I was able to find the range. We have the domain and range of the actual function. Now, the question was not about finding the domain and range of the actual function. The question was about finding the domain and range of the inverse function. For this value of k, find an expression for f inverse of x. We are done with that. and state the domain and range of the inverse function. So this was basically the question. Now, according to the rule that we discussed yesterday and I've told you today as well, I'll be writing it down now. Okay. All right. Now let's talk about the domain of the inverse function. Okay. Now, students, please pay attention. Again, the question is about the domain. I'll write down X here. But the rule says the domain of inverse function is same as the range of the function. This is the range. The lower limit is -11. The upper limit is 5. So X would be greater than equal to -11 and it would be less than equal to 5. Okay. This is how we write down the domain. Whenever the question is about the domain, please make sure that you have X here. And yes, if it's about the domain of the inverse function, then you need to see the upper and lower value by looking at the range of the actual function. Okay. This was about the domain. Now let's talk about the range. So range of the inverse function. Now, we are talking about the range of the inverse function. We're talking about the range of this thing. Here we were talking about the range of this value. So we had f of x here. Now we are talking about the range of f inverse of x. So I'll write down f inverse of x, and the upper and lower limits would come from where? We are talking about the range of the inverse function. So I'll be looking at the domain of the inverse function. Domain of the actual function. Okay. So the actual function is this. So the lower limit is 2 and the upper limit is 6. So it would be f inverse of x is greater than equal to 2 and it's less than equal to 6. So this is going to be the answer. Any confusions with this? Let me repeat it once again, then let me know if you have any queries, because after this we will be switching to past paper questions and then we will be using this knowledge there directly. Okay. So far, forget about everything. Forget about composite functions. We are discussing a function and its inverse. A function's domain and range and the domain and range of its inverse. Whenever the question is about the domain, you will be writing down X here. Whenever the question is about the range of f of x, of f inverse of x, it depends. Okay. So whatever thing you have over here, you'll be writing it down over here. Okay. Here we had f of x. So I wrote f of x here. This is just some important stuff about the notation and about the values. So if the examiner is asking about the domain and range of the inverse function, just go to the actual function, and if the question was about the domain, find the range of the actual function, and if the question was about the range of the inverse function, find the domain of the actual function. Okay. Now tell me if you have any confusions or anything that you were not able to understand. Yes, please ask me.
No, Miss, anything fine.
Okay, great. Munja and Ahmed.
Explanation.
Clear, ma'am.
Okay, all right. Okay, perfect. So that is it. I will be going back now to the PDF I made for the past paper questions. Okay, so this is the exam. Basically, 1 second. All right. Let me just zoom in. This is the exam. You can just note down the exam. And let's start solving it. Okay. I would expect some sort of, answers from you guys as well, but overall I'll help you because this is the very first question. Okay. All right. Now, question number 7 of this exam says functions f and g are defined by. Okay, that's just a way of writing down f of x and g of x. F of x is 3x minus 2 and x belongs to the set of real numbers. Now, when they just write this much, it means you have the entire number line. You have every number of the number line as your domain. Okay, you have positive numbers, you have negative numbers, you have zero, you have decimal numbers, every number that is there on the number line. So that is what it means. Okay, g of x is 2x plus 3 divided by x minus 1, and then the domain says x belongs to the set of real numbers and x is not equal to 1. It means every number on the number line except x equals 1. Why do we have this here? Can anyone tell me? Any idea about it? Why is it like this? Why can't we use x equals 1 and g of x?
Because if we say 1 minus 1, it would be 7. We cannot.
Very well done. Excellent. Very good. Okay. Because if you look at the denominator of g of x, you can see x minus 1 there. When you have x minus 1 there, and now if you plug in x equals 1, it would give you 1 minus 1, that is 0. And just use your calculators and just try solving any fraction that has 0 in the denominator. You would come across an error because that's infinity. Okay. So in general, it's a rule. You will get to see that again and again. Whenever we would be having a 0 in the denominator, that would be that should be considered as an error. Okay, I'll come back to it after we are done with the first part of the question. For now, just forget it. These are the two functions and we have their domains, and let's read the question. Obtain expressions for f inverse of x and g inverse of x. Now I'm pretty sure all of you would be able to find the expression for f inverse of x. Please do that. Please do find an expression for f inverse of x, and then I'll tell you how to find it for g inverse of x. Okay, take 2 minutes and do this part. Very well done, Rafi. Excellent. Very good. And I'm pretty sure all of you can do this. I know this. Okay, just do it with confidence. Just know that you can do it. Take another minute and send me your answers, please. You are only supposed to do the first part of the question, that is finding f inverse of x. That is it. Okay. So let's do it together then. So again, there's no point in writing it down as step 1, step 2, step 3, because this entire question is for 4 marks. So you can even write down the answer directly. That's also fine. Because for this very part, you would only get 1 mark or so. Okay. So there's no point in wasting too much time. But still, for the sake of completeness, let me explain it to you. Step 1 is writing down f of x as y. So this would give you y equals 3x minus 2. Now just interchange x and y, and it would give me x equals 3y minus 2. And lastly, I need to make y the subject. So this would give me x plus 2 equals 3y. And finally, I would get y equals x plus 2 by 3. And since the question was about finding f inverse of x, not y, so I'll write it down as f inverse of x is basically equal to x plus 2 by 3. So this was the first part of the question, and this was an easy function. So we were able to find the inverse very, very easily. That's fine. Let's talk about the second part. Okay, I'll be raising the first part because the second part is more important. Or let's just keep it. I'll just scroll down. Okay. Now for the second part, you have been asked to find g inverse of x. Okay. Now we are working for g inverse of x. Okay. Again, how do we do it? Just write down g of x as y. So it is y equals 2x plus 3 divided by x minus 1. And now just interchange x and y. So this would give you x equals 2y plus 3 divided by y minus 1. Now you need to make y the subject. So I'll take this entire thing on the other side and it would give me y minus 1 into x equals 2y plus 3. I'll expand and it would give me yx minus x equals 2y plus 3. And now I would get yx. I'll take this 2y on this side. Yx minus 2y equals, and I will take this minus x on the other side, so it would become positive x. I can take y common and it would give me, let me do it properly. When I will take y common, I would be left with x minus 2, and this is 3 plus x, and finally y is equal to 3 plus x divided by x minus 2. And please don't forget to write down g inverse of x, because this is what you were asked to find. So g inverse of x would basically be 3 plus x divided by x minus 2. Now, if I tell you honestly, this finding inverse of this type of a function is considered to be difficult. Okay, so if you were not able to understand, please don't be shy. Just tell me directly if you were not able to understand, because this is important. Okay, one second. I hope that you guys are able to see the entire screen. Okay, g of x was the function now. And how have we done it? Step 1 was just writing down y instead of g of x. Step 2 was interchanging x and y. Step 3 was making y the subject. Now, for such scenarios where you have a variable, both the numerator and denominator, and you need to make it the subject, it is a bit complicated, but trust me, the method is same. Every time I would be taking the denominator on the other side like this step. I've simplified, then I have taken 2y on the other side and minus x on the other side. Then I took y common and I was able to make y the subject, and I was done. Lastly, please make sure that you write down g inverse of x instead of y, and this is going to be the answer. Any confusions with finding the inverse of g of x? Yes, please feel free to tell me. Okay. All right. Emma, then Munja, are you sure that you have understood this?
Yes, ma'am.
Okay. Yes, ma'am. All right. Perfect. Okay. Now we had one last part of the question, which I would expect from you guys. Stating the value of x for which g inverse is not defined. Okay. This is the last part of the question. So G inverse is in front of you. Here it is. This is basically G inverse of x. So what do you think? For which value of x would G inverse of x would not be defined? We have just discussed that. It is about the denominators. It is about not having a zero in the denominator. So for which value of x you would have zero in the denominator?
2.
Very good. Excellent. Okay. So it would be x equals 2, and this means that we cannot have x equals 2 because this would give you an error. So stating the value of x for which G inverse of x is not defined, and that value would be x equals 2. Yes. Okay. So you can just write it down this way. And please try writing down the entire statement. G inverse of x would not be defined at x equals 2. Make sure that you write down the entire statement, because for the examiner, he's actually making the exam, but those who are checking your paper are basically given the marking schemes. Obviously they have no maths as well, but still we need to be sure about everything. So it's good that we just write down tiny small elaborations for such parts, because you would get 1 mark for this part. Okay, so the mark distribution was basically this. It's a 4-mark question. So 1 mark for F inverse, 2 marks for G inverse, and 1 mark for this last part. Okay, you had 2 marks for the G function because it was a bit complicated. Okay, so please make sure that you do a good number of steps according to the number of marks. Okay, let's talk about the second part of the question. Okay, now the second part says solve the equation f of g of x equals 7/3. Now this is basically a composite function. Okay, we have discussed composite functions, so you would get to understand everything. I'll be writing down f of x and g of x again. F of x was basically 3x minus 2 and g of x was a fraction 2x plus 3 and x minus 1. Okay, and also one thing to avoid silly mistakes, whenever you are writing down something, please double check that if you have written the function correctly. We had 2 functions here. So f of x is 3x minus 2 and the other one is 2x plus 3 divided by x minus 1. Okay, it's correct. Now you have been asked to find fgx. This is what we have. Okay, fgx is basically f of g of x. So how do we write it down? When we had f of x, we had x here. Now when you will have g of x, we will be writing it down 3 and then something minus 2. And in that something, we will be writing down g of x. So that would be 2x plus 3 divided by x minus 1. Okay, this is basically f of g of x. Okay, so I'll be writing it down again. fgx is basically 7/3. This is the equation that you need to solve. So we got the expression for the composite function fgx, and that is 3 into 2x plus 3 divided by x minus 1 minus 2 equals 7/3. Please try simplifying it and find the answers of x quickly. It's very easy. We know how to solve linear equations. We will take this minus 2 on the other side, okay, and it would become 3 into 2x plus 3 divided by x minus 1 equals 7 by 3 plus 2, and that would give you 13 by 3. Now I can just take this 3 on the other side, this 3, and it would, you have multiple ways of simplifying this equation. Obviously, this is just my way of doing it. It's 2x plus 3 divided by x minus 1 equals 13 by 9. Now I can just cross multiply, and it would be 9 into 2x plus 3, and it would be 13 into x minus 1. So 2 into 9, 18x plus 27, and then 13x minus 13. I'll take this over here. So it would become 18x minus 13x, and I will take this 27 on the other side. So it would become minus 13 minus 27, and this would give you 5x equals minus 40. And this would give you x equals minus 8. This is going to be the answer. So the understanding part of this question was basically we had a condition. Look, it's a 3-mark question and it was very easy. After finding the composite function, how did we find the composite function? So when we have f of x, we had x here. When you will have f of g of x, you will have g of x here. Okay, this is what you need to understand. And after simplifying and equating it to 7 by 3, I made x the subject, and it turned out to be that x is equal to minus 8. Very well done, Rafe. Okay, what about the other students? Are we clear with the idea, Munja and Ahmed? Any confusions with this part?
Ma'am, can we repeat the first part, please?
Definitely. The first part, like the first part of...
Yeah. Where it says fg of x is equal to 7 over 3. Then the next line there.
Okay. Are you talking about this one?
Yeah, the line below. I mean, I think because
Okay. I'll tell you. So basically,
my frozen.
Okay. Can you see this? Can you see it now? Is it moving?
Yeah.
Okay.
Yeah, it is moving.
All right. Okay. I'll explain it again. Don't worry. So the condition was given, that was f of g of x equals 7 by 3. In first part of the question, we have done this. And here we have basically just worked on finding out the composite function f of g of x. Okay. So f of g of x turned out to be this: 3 into 2x plus 3 divided by x minus 1 minus 2, and this was equal to 7 by 3. Then I've just taken this 2 on the other side. So 7 by 3 plus 2 would give you 13 by 3. I've just done that directly. 7 by 3 plus 2 would give you 13 by 3. And then I took this 3 on the other side. You have, obviously, you have multiple ways of solving this question. This was just my way of doing it. When I took 3 on the other side, it was multiplied with the denominator. We had 3 already. 3 multiplied by 3 would give me 9. And at this point, I have just cross multiply. So after cross multiplication, we had 9 into 2x plus 3 equals 13 into x minus 1, and then it just became a linear equation, and I made x the subject, and it gave me x equals minus 8, right? Yes. Any confusions with this, students? Please tell me. Any difficulties with this question?
No.
No, ma'am.
Okay, all right. So just give me 1 second. Let me just stop the recording.